Okay, hello everyone. So let's start our lecture today. So I'm going to continue the IV regression, and I'm going to give you some examples. We're going to talk about the IV assumptions, and we're going to discuss how to estimate the model, both just manually, like we can do it manually, and the other option is to do it just one shot in Stata by just using one command. So we're going to be talking about both because I always want you to understand how the computer works. So we're going to learn both ways. Of course, in most applications, after you learn that, you're just going to do the command. Like one shot, you just get the results. But it's very important to understand how it works. All right, so before we start, let me just go over the most important point that we were talking about last time and how we're going to expand on it. So last time, we were talking about how to estimate the IV regression model. We started with a very simple model in which just we have one X, okay? So we just had one X to be estimated. Where is it? Just let me, okay, let me write it again here. So we started with a model that was very simple, where Y I was equal to beta 0 plus beta 1 xi plus ui. And our problem was the connection between the error term and the x. Okay, so whenever I have this connection between the error term and the x, we call it x being endogenous. Okay, so endogeneity problem. So X is being endogenous, or you can call it endogeneity problem, because of the connection between the xi and ui that is not equal to 0. So there is some connection between the two. So our idea is we want to try to find an IV for X. So I want to find an instrumental variable for X, and we decided just to name it Zi, that can be a good representative for X, that could be correlated with X as much as we can, right? And we can use it in order to extract out of X the good part, or extract out of X the exogenous part, and use it, or use the exogenous part of X to estimate our model. So what we were talking about last time was two stages least squares, which is our estimation model. And we said that the two-stage least squares is, as the name suggests, it basically goes into two steps. So in step one is just the filter step. You can think of it as the filter step. You're going to filter X into two parts. The part that is, we call it problematic, and a part that is a problem-free or non-problematic part. Okay, so once we are able to split X into two parts by doing a regression, so xi here as a function of zi, we are able to get an estimated version of X that we call it xi hat. And this is the good part of X, and we really don't care about this. We don't need this part. Okay, because this part is the problematic part of X, the part that is still endogenous. So in step number 2, we actually took the non-problematic part of X, or we call it xi hat. Okay, so we took this non-problematic part in order to estimate our main model. So we went back to our model and we plugged in xi hat instead of xi. And by doing so, we are able to get consistent estimators, or consistent delta node, and I keep saying delta, I'm sorry, lambda node and lambda 1, and we call it the TSLS estimator. So we were able to get consistent estimators by doing the two-stage least square methodology, or estimation methodology. Okay, so what we did last time is we tried to expand this model. Like our models are not just y as a function of x. It's y as a function of set of x's or a set of regressors plus a set of other variables that can be classified as being exogenous or non-problematic by nature. Okay, so we're going to write a model in terms of a set of x's that are endogenous and a set of w's that we call them exogenous by assumption. And we stopped last time by saying that, again, we're going to be estimating this model in 2 stages. And I asked you to try to see how the stage 1 and stage 2 would look like. So again, we're going to repeat what we have done, but in an expanded version. Now, I don't have just one x, I have multiple x's. So we're gonna start with the first x. So x1i. x1i has to be, or is a function, or is estimated as a function of the set of instruments I have in the model. So we're gonna be using all the set of instruments that we have as z1i plus z2i plus z3i plus the very last one, which is alpha m z mi. So all the instruments I have in this model, whether these instruments are used for x1 or x2 or x3 or xk, I'm going to be using the whole set of instruments for the regression of x1, and I'm going to be doing the same for all other x's. I also have to include the set of exogenous variables. So we're gonna have like m plus 1 w 1i plus all the w's alpha m plus, let me make more space here. Oh my God. Okay, because this is a, I wrote it last time. Okay, let me just have it this way. Okay, so m plus r w r I plus the error term vi. Okay, so this is our first regression. So the idea is we're going to regress the first endogenous variable on the set of instruments that are used for all the x's and the set of exogenous variables. Why I'm using the exogenous variables in this set and this regression? Because the idea is I want to extract the good part of x. I want to get the exogenous part of x. So anything that can help me to get the exogenous part of x, I'm going to include them. I wanted to notice that these exogenous variables might not be related at all to x. Okay, so I might have this set of coefficients insignificant, which is really won't affect my regression, or I might get them statistically significant, which would help me to extract the good part of x. The second regression is going to be for x2i, and I'm not going to like write all the set of x's. Okay, I have to, okay, let me write it just here. Okay, so you're going to do it for x2i, x3i, and so on, and xki, which is our very last one, and I'm going to be using a different coefficient. So let's use lambda naught plus lambda 1. Again, you're going to be just copying and pasting everything on the right-hand side, z1i plus, but just name the coefficients differently because you won't expect them to be the same, right? Plus alpha, sorry, I called this one, plus lambda m plus 1 w 1 I plus lambda m plus r w r I plus, so we're going to have another name for the error term, let's say epsilon I. Okay, so again, whatever you have after the equal sign are exactly the same. I just had different notations for the coefficients. And again, the idea is to extract the good part of x to get the part that is non-problematic of x. Okay, so out of this stage, we're going to get estimates for, and that's what we want, right? x1 I hat, x2 I hat, x3 I hat, xk I hat. Okay, and these are the non-problematic x's. Okay, so these are the non-problematic x's, or the exogenous or the good parts of the x's, or the exogenous or the non-correlated with the error term part of the x's. So these are all equivalent. Okay, next we're going to go to stage number 2. In stage 2, we're going to repeat what we have done, right? So in stage 2, we are going to, and I'm going to just remind you what we did in stage 2 when we had the simple model. So in stage 2, we were regressing yi on the good x, and we had just one x. We had a very, very simple model. We're going to repeat this exact equation but by expanding it, okay? So we're going to have, again, in stage 2, we're going to regress yi hat on beta naught plus beta 1 x1 I hat, okay? Okay, I'm sorry, this is not xi, this is the yi, the main model, okay? Plus, you keep going, beta k x ki, and this is hat again, plus beta k plus 1. I'm going to have all the set of exogenous variables I have, plus beta k plus r w r I plus whatever the name of your error term, let me call it whatever name. So this is your error term, okay? And the betas that we're gonna get, like beta hat naught, beta hat k plus r, these are the 2-stage least squares estimators. Okay, so these are the consistent estimators, and you can actually call them TSLS right after, like under here, so that you know that these are the 2-stage, these are the non-OLS estimators that are supposed to be consistent estimators. Okay. So let me give you an example. And the example is from your textbook, so page 529. And sorry, oh my God. So in this example, it's in page 529 to 530, and it's a good example. So what we have here is we have the log wage. We have been like talking about this model since the beginning of the semester. Beta naught plus beta 1 education plus beta 2 experience plus beta 3 a quadratic term experience squared plus ui, and everything has an I. Okay, and the assumption is these two are exogenous. So this is by assumption, okay? This is a problematic variable and is endogenous. What do we mean by endogenous? By endogenous, we mean that we expect that the correlation between education and the error term is not equal to 0, okay? So when you try to think about this variable, which is education, you think about this is like other factors, right? And when you think about what's included in the other factors is, let's say, whether your parents are educated, whether family income, so many other factors, right? When you can think about like culture, right? When you think about any other, like age, think about so many factors that might be inside here. And when you think about these factors in education, there must be some kind of connection. Okay, so you are trying to think about how can I break this link between education and error term. So one of the instruments used in this model is the father education and the mother education. Okay, and the idea is there must be some connection, right? If I'm talking about the IV relevance or relevance test, which is about, I think that there must be some correlation between the problematic variable and further education as a variable. This connection is not equal to 0. So you're making an assumption, like when you're thinking about it, you're making an assumption thinking that there must be some connection that makes this IV relevant. There must also be some connection between my education and mother education. You expect that when the family or the dad and mom are educated, most likely their kids are also going to be educated, and that's the basis of the assumption. Okay. The other thing is you need to assume that, or you need to base your choice of your instruments on exogeneity. So IV okay, so you want to see whether is there any correlation between father education and the other variables that affect my wage, right? Is there any connection? There might be, but we want to check. We want to check whether it's statistically significant